Hi everyone, this is lesson electric force, and in this lesson we are going to solve one question based on Coulomb's law and electric force. So in this question we have two pith balls hanging from the same point by insulating thread. Each pith ball has the mass of 5 grams and each thread is 1 meter long. The balls have identical charges, so they repel each other. This repulsion causes the threads to separate by the total angle of 30 degrees. So here we are required to find the charge on each ball. So in this question, we are going to find the charge on each pith ball. We will solve it in three main stages. First, we will use the symmetry and geometry of the diagram to find the angle for one thread and the distance between two balls. Next, we will draw a free body diagram and use equilibrium condition to calculate the electric force acting on one ball. Finally, we will substitute the electric force and separation distance into Coulomb's law to calculate the charge on each pith ball. So before we start calculating, let's write the main physics ideas. So the mathematical form of Coulomb's law is Fe equals K times Q1 Q2 by R square. Since we know in this question the pith balls have the same charges, we can write this as K Q square by R square, because Q1 equals Q2 equals Q and Q times Q would be Q square. Now, since the balls are at rest, we can say the system is in equilibrium. And if the system is in equilibrium, net force is zero. It also means that vertical force would be balanced and horizontal force will also be balanced. Another concept, like charges repel each other. And why the balls separate? Because of this property of the charges, that they repel each other if they are of same nature. Now let's work on the geometry. So the question says the total angle between the two threads is 30 degrees. Because the setup is symmetrical, each thread makes half of that angle with the vertical. So if the total angle is 30 degree, half of the angle would become 50 degree. Need the separation between the two balls. This separation is not the length of the thread. The thread length is 1 meter, but r is the horizontal distance. That is going to be the separation between the two balls, which we are required to determine. Now, to determine that separation, we are going to use this right angle triangle that has been formed. So here you can see the opposite to theta is r by 2 and this hypotenuse is L. So hypotenuse of this right angle triangle is L. The opposite of this right angle triangle is r by 2. So using the ratio sine theta, we can relate r and L together. So sine theta is opposite over hypotenuse and opposite is r divided by 2 divided by hypotenuse, which is L. So we can write sine theta as r by 2L, and r will become 2L times sine theta. So we can write the relation that r equals, so we can write this relation r equals 2L sine theta. L is already given to us in the question, which is 1 meter. Theta that we have determined is 15 degrees. Now we can substitute this to determine the value of r. So it would be 2 times 1 times sine 15 degrees. On solving this, we will get 0.518 meters. So this is the distance between two pith balls that we got. Now we will focus on just one pith ball and we are going to set up the free body diagram and we are going to use the equilibrium conditions to determine the vertical forces and the horizontal forces. So the forces that act on one pith ball would be first would be gravitational force. Since the pith ball contains some mass, so of course gravitational force would be along the downward direction and will be equal to mg. So Fg equals mg. Now we had the other pith ball which was also positively charged. So this positively charged pith ball is going to repel this pith ball towards the east side. So this is going to experience a repulsive force from this previous pith ball. Another force is going to be tension along the string with which this pith ball is connected. So I'm going to draw the force tension. So as you can see here, this pith ball is experiencing three forces: one tension along the string, one gravitational force vertically downwards, and one repulsive force towards east. Now you can see tension is the angled force. I will draw the reference vertical line also, and this angle is theta, which is 15 degree, which we have computed earlier. So this angled force should be resolved into its vertical component and horizontal component. So this is the horizontal component of the tension force and this is the vertical component of the tension force. So the horizontal component of the tension force can be written as T sine theta and the vertical component can be written as T cosine theta. We have used the basic trigonometry. We know the system is in equilibrium. So net force on the pith ball would be zero. So we can say horizontal forces would be balanced and vertical forces would be balanced. So the vertical forces are T cosine theta acting vertically upwards, which would be balanced by the vertical downward force, which is mg. Let's mark this equation as 1. Now, horizontal balance, we have two forces which are horizontally present, which is T sine theta towards west and Fe towards east. So they are also going to be balanced. So we will write T sine theta equals Fe. Now I can divide these two equations and we will get the electrostatic force Fe. So 2 divided by 1, I will write T sine theta divided by T cosine theta, where I'm dividing LHS with LHS and RHS with RHS. So Fe divided by mg. Now T and T can be cancelled and the ratio sine theta and cosine theta would become tangent theta equals Fe over mg. So now we can just isolate Fe and Fe would become mg times tan theta. We can determine Fe by substituting the values. So the mass of the pith ball is given to us, which is 5 grams. So 5 divided by 1000 because we need to convert it into kgs. So I'm doing 5 divided by 1000 here. G is the known value, which is 9.8 meters per second squared. Tan 15 degree equals Fe. Now on solving this, we will get 0.0131 Newton, which would be the value of electrostatic force. So electrostatic force between the two pith ball is 0.0131 newtons. This value will now be used in Coulomb's law to solve for the charge. Now we know that Coulomb's law is Fe equals kq square by r square. Now I can isolate q square. So Fe equals kq square by r square. I would write Fe times r square over k would give us q square. And now I can just write down q equals square root of Fe times r square by k. Now I can substitute the value of Fe. So we got Fe as 0.0131 Newton. So 0.0131 Newton times r square. R we had already determined earlier. So r came out to be 0.518 meter. So it would be 0.518 square. K is the known value, which is 8.99 times 10 raised to the power 9 Newton meter square per Coulomb square equals Q. Now on solving this, we will get Q equals 6.26 times 10 raised to the power negative 7 coulombs. So Q equals 6.26 times 10 raised to the power negative 7 coulombs, or we can also write 0.626 microcoulomb. So this is how we have determined the value of Q. Now let's summarize the important values. We found theta by splitting the total angle in half. We found R using I equals 2L sine theta. We found electric force using equilibrium. Then we found Q using Coulomb's law. And now let's look at some common mistakes that we do use while solving this question. So mistake 1 is sometimes we use 30 degrees instead of 15 degrees. So make sure that you are splitting the angle into two. Mistake number 2 is forgetting to convert grams to kilograms, which is very common mistake. Another mistake that we might do is using the thread length as R. So the thread length is 1 meter, but R is the separation between two balls, which we have calculated using the trigonometry. So we have to use the force balance before Coulomb's law, then we can easily find the charge using the equation that we had determined.